Hi everyone, welcome to the new video. So today we'll see troubleshooting the ephemeral storage issue in Kubernetes and how we can, debug it or prevent it in future. So without further ado, let's start. So we'll see troubleshooting ephemeral storage and how we can, put solution for future to prevent it happening from future. So first of all, before understanding this, we'll understand what is ephemeral storage. So ephemeral storage is a temporary data which is written by containers on the node local disk. So where on the nodes, on the worker nodes, where the our pods are running, inside the pod we have containers. So all the containers will use the same node local disk, and sometimes these nodes are not permanent, they are ephemeral because till the time till the time pods are the pods are there, it exists only then. Once the pods are removed, the data also get removed. Okay, so what happens, we can say that it is not backed by persistent volume. Data is stored on the node's root file system and it is shared by all the containers running on that node, and Kubernetes monitors it and can evict pods when it is low. So this issue, why it is, it's difficult to trace, because till the time you won't get any, if our alerting or monitoring is not monitoring our ephemeral storage space, our pods will get evicted suddenly and our application will come down and we won't be able to trace it because pods are not there. We will not find any trace in in the events, the Kubernetes events. We will not be able to find it, the logs. So that's why proper monitoring is very important. You'll see, if the proper monitoring is not set, you'll see everything is up and running, there are no alerts, and that's why not able to get you'll see that suddenly your pods will come down and will start evicting and your application will come down. So ephemeral storage are temporary storage and it is tied to the pod, deleted when pod is removed and stored on node disk. Persistent storage are long term, independent of pod, survive pod restart, backed by PV. So what consumes ephemeral storage is the application logs, which are stored, writable container layer, empty directory volume, temporary volumes defined in the pod, or caches or temp files under the temp folder, container images, which are uncompressed image layer, and heavy layers, which are stored on the node. So what happens when there is a node disk usage increases? So node enters a disk pressure state and kubelet is always monitoring the node file system. When it sees that a node has entered a disk pressure state, it will start evicting the pods to free up space. That's why if we are not monitoring the storage of node, we won't be able to trace, and by the time when we'll see that, we'll able to find that this was because of the storage issue, it will be very late. Okay, so that's why it is very important to set request and limit for ephemeral storage in pod. It is monitor, we should have proper cleanup scripts available and proper alerting system available. How we can define request and limit, like this CPU, memory, because if we are defining request and limit also in this way, that much in limit it will use the storage of the storage. Now what happens when the app writes the disk fill, and once the disk fill the 95%, it creates disk pressure and pods start evicting. So what Prometheus matrices we should use is container fs usage byte, which means that how much file system of container is left. So by this matrix we can get the container usage of the file system, each container. Then we should have node file system available, bytes like of that particular node, how much file available or free space is there, and the queue pod info, like so every pod metadata. So we'll combine all these matrices and we'll get, like, we can. So by using these three matrices with proper filters, we can get the information that particular namespace is using this much space of the node, and how much is left. These are Prometheus matrices. Apart from Prometheus matrices, if we are using proper PromQL queries, Prometheus queries, we can get more efficient data. That we are calculating the container file system usage, like what each container, how much file system storage it is using, but at what rate. Like if 30 minutes before the it was using 10%, then after 30 minutes it's using 50%. So by this rate we can calculate that which container is consuming more space, how much. So we should apply proper queries and proper visualization, that whenever we have to trace it and if set alerting, we can have we get instantly what is going wrong, and we can apply fix. We can use top command to get top 10 container which are performing worst and they're using lot of space. So this is the query. So basically Prometheus matrices, what we'll use, matrices are like the data with the time series event, and with the proper PromQL queries we'll combine those matrices and we'll use it. We can filter it according to namespace, according to application. Okay, then we can use visualizations of these matrices in Grafana. We can use it, we can create it with a heat map, we can create it with the node free space, pod restart, how much pod is restarting, storage trend. We can show it in various ways. So heat map is like visualizing density, intensity over time dimensions, and the color of the heat map shows like how color scales basically define how much there is a variations with time and this event. Then the best practice is we have to use the request limit that we have already seen for the pod storage. We should always use log rotation, because after some time the logs which are too old should be removed or should be moved to some other space, or we should use external logging, or we should use predictive alerts, so that before anything worse happen we are alerted and we can apply the fix. We can for the temp folders we can have a script of cleaning up temp folder. So these things will help up preventing it in future. But this is one of the reason why pods start evicting and we don't know the reason, because of proper or poor monitoring or an observability implemented. So that's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.